Hi, and welcome to our last module, Module 6, in which we discuss future trends and developments. Now, most of you have heard the new hypes about artificial intelligence. You have worked, I'm sure, with plenty of digital tools. So we want to talk a little bit about some new developments or some, general, kind of provide a general understanding of what digitalization and artificial intelligence are, what's their relevance to new product and service development. And we now we have a new hype term, that's artificial intelligence. The previous hype term that people are now starting to abandon slowly was big data analytics. The last 10 years, we've seen lots of not only research, but also practical discussions, but also discussions in the popular media. You've seen a lot of job descriptions that add this requirement to new job applications. But essentially, those two are intrinsically connected, right? So the foundation for artificial intelligence, or a lot of the artificial intelligence that we have today, is the fact that we've been aggressively collecting data in the last 10 to 20 years. And so when we want to think a little bit about that, right? So big data, what have big data sets brought onto the table? Certainly, we are capable now to measure customer relationships a lot better. We can assess our competition. We can develop a strategy. We can develop our business models, and we can also potentially improve our operations. Whether data analytics or data collection or artificial intelligence by extension will provide a positive return for a company will largely depend on those adjustments that these firms are taking place, and of course a bunch of contextual factors that we are noticing here. All of us, we use search engines. Now we use a little bit more of ChatGPT, but yeah, search engines, social media, business transactions, platform ecosystems. We talked about some of these in previous modules, but what we didn't talk as much about, although we have some case studies like the Uber case study demonstrates, is that data is really valuable. And using data to actually design new products and services can turn out to be very helpful. And AI is essentially putting another additional spin to those efforts. And of course, ChatGPT kind of showed the potential of generating text and other interesting options, but big tech companies have been using algorithms for a long time, right? So we'll talk a little bit about that. Scope of data analytics, typically we have three different types: descriptive, predictive, prescriptive. Some of you might have taken data analytics classes or workshops, or you've done your own research. This module is really not here to discuss statistics in detail, but just giving us kind of a general context of how we should, think about big data and how this are relevant to our to new products and services. Netflix, all of us kind of seen and know Netflix. Data and the collection of data is also intrinsically tied to metrics of success, right? So, and of course, to the business model that each of these companies are operating. Netflix, with the ability, and we'll talk a bit more about that later, Netflix with the ability with streaming and their website, collecting data and looking at customer reviews and customer behavior, certainly initiated a let's say, data war, so to speak, with Blockbuster, who, as you know, had physical locations, and they definitely must have had data systems and databases, but they had different metrics of success, and their metrics of the data was coupled to different metrics of success. In Blockbuster's case, optimize inventory, maximize rentals. In Netflix's case, maximize subscriber retention, customize content to user profile, right? So that those are kind of different. Now, there are different kind of contextual factors and categories to really think about that, right? A company can have different data size and types. They might use data scientists and analysts. They have a certain information technology infrastructure, and they also integrate this potentially throughout venture operations and supply chains. This is what we call analytical capabilities. It's also, if we think about absorptive capacity, and you know, we talked about this in Management 519, kind of core competencies and core rigidities. These analytical capabilities contribute to those, right? And so then we have an organizational context, right? So type and size of firm, number of employees, revenue, et cetera, et cetera. We have firm capabilities per se. We just talked about absorptive capacity. Then we also want to have some results on these, whether it's asset maximization, customer acquisition and retention, novel value proposition, or generating a sustainable competitive advantage. So that's broadly the structure that we are encountering when we discuss about new data and analytical capabilities. And we'll talk about how AI kind of fits into that in just a little bit. Now, as you can imagine, right, with the emergence of big data and the emergence of the ability to leverage data for competitive purposes, there are also different distinct competitive strategies that came out, right? So we have analytical capabilities, okay, that become a strategic competitive advantage, right? That becomes the primary focus in a particular area of business. For example, Netflix predicting customer movie preferences. Marriott is looking at revenue management. We have enterprise-wide analytics, right? So one of the key problem of big companies is how do we actually build consistent metrics throughout the company, right? So typically different departments and different divisions have different sets of metrics of success. They collect different types of data. They usually store data in their own databases, right? So not every division has access to data of the other division. That creates these, what they call fiefdoms. And so it's important to actually create that and be able to do that. And so good examples are Bank of America, RBC Financial Group. Typically, banks do a pretty good job with that. We talked about, we had the case study of Eastern Bank, right? And so they're essentially trying to build this online loan application system. And they have kind of this friction, right? Where how much of that are they willing to share with the other parts of the bank? So that's kind of an example where we see these things not always working really well, or having some trouble to set that up. We need senior management commitment typically, and we've seen this in Eastern Bank, right? If you don't have senior management commitment, you're gonna have trouble to convince everybody to be on the same page, right? And so that's kind of an important issue. And then, of course, you can use these analytical skills to also create a change in your business model or kind of a change in the way you're operating. And so we used to, if you look at the airline industry, they used to measure their performance in a different way, right? They're typically look at cost savings, customer spending, employee productivity, and those are all good, right? So they're not wrong measures. But a new metric that we've seen became very dominant in the last couple of years for airlines is looking at yield management and price optimization of airline seats, right? So we have entire airlines that are dedicated to provide to offer dynamic pricing, such as Spirit Airlines, that certainly came with some caveats, but generally speaking, right, when we think about analytical competition or analytical capabilities, those can influence a whole set of company outputs and strategies, but also, of course, new product development, right? New product and new service development, and nothing has. We have seen this definitely very clearly in the big tech companies, right? Whether it's Apple, whether it's Google, whether it's Meta, whether it's Netflix, whether it's Amazon, et cetera, right? So big tech companies that have used and leveraged data as well as algorithms for a while, their capabilities to develop new products are strongly connected to these tools. And again, this is kind of a overview of what kind of stages you have in analytical competition, right? So you have something that's called analytically impaired. Then you have localized analytics, right? So you have different divisions who are essentially developing their own analytical tools. You have something that's called analytical aspirations, right? So then you kind of are in between. You start to develop enterprise-wide analytics, but you're not quite there yet. You have analytical companies and you have analytical competitors. You're essentially using your data very strategically for your competitive advantage. Again, so this is just a little bit more detail here. Again, we talked about kind of how these different companies can have these different levels of analytics capabilities. Typically, we do have some ability for analytics. Okay, it's rare that we have big companies that have none. There might be still a few out there, but it's important to understand, right? Like it's important to understand what happens in your business, and to do that, to answer that question, you really need to have the right data. You have to understand what data you need to collect. You need to have the right data collection tools, and then you also have the capabilities to analyze what you collect. And so again, these different stages are also related to your industry. Some industries are more analytics intensive than others. And so typically companies kind of adjust to these different levels differently. But that's, just giving you kind of an overview to think about this a little bit and kind of see where you or your future employer potentially sits. Here are some examples. Marriott does revenue management, UPS, operations and logistics, customer analytics, HSBC, right? Any bank does risk, credit scoring, pricing, Harrah's, customer loyalty and service, Tesco, customer loyalty. I mean, a lot of grocery stores, they collect a lot of data on you through these loyalty cards. So what they exactly doing with the data, that's a different story. But typically, if they want to use it for themselves, that helps them a lot to figure out which items or which products are doing well, but what customers' profiles in terms of purchasing certain products. That also helps a lot in tracking how certain new products or brands that you want to introduce are going to go and how well they're going to do. And you can get that information in real time. That's a big advantage. Again, other companies, Capital One, Google, ISM, they do different types of things with that data, and you can, look through any other company and see how they're doing in that sense. So typically what we have, right, we talked about these different levels of analytical competition. When you're analytically impaired, right, and what that means is you haven't set the right systems in place, you're not very data focused, right? You want to kind of change that, and typically that happens through senior management or managerial pressure. You start building some momentum, right? You kind of start building these analytics capabilities, and for most, that's where things end, right? So stage 2 is typically where things have ended, because if the more you integrate, right, the more data you want to kind of you want to collect across the organization, the more work you have to do in terms of your organizational change and organizational design path, right? And obviously, the end goal that you want to achieve is that you're gonna use enterprise-wide analytics, and you're using them, and these analytics capabilities actually have a positive impact on your firm outcomes. Now, we talked about big firms. For entrepreneurial ventures, it's actually quite interesting because those have typically face a lot less resistance to impose these or build these analytical capabilities, especially because a lot of these entrepreneurial ventures, if they want to launch new products and services, they want to know exactly how the customers respond to it, right? So, and they are dependent on it in order to be competitive and in order to create a competitive advantage or a differentiation to the big companies. And so they are definitely more open to do that. In fact, a lot of startups and entrepreneurial ventures, they are very data oriented. They're not always collecting the right data. They might not always, have the organizational processes in place to take advantage of it, but they most certainly are very open to do that, right? Because for them, it can prove to be a massive competitive advantage. And so, yeah, and some of the things, of course, with entrepreneurial ventures, these analytical capabilities are capital intensive to a degree, although now with cloud computing and other types of infrastructures that you can rent essentially, so you don't have to build your own, that is certainly helping entrepreneurial ventures to be more competitive in that. Now we're taking a little more detail on what are kind of constructs that describe digitalization, also including artificial intelligence, but what is needed, right? We talked a lot about analytical capabilities, but what is actually needed on an individual level or in competencies in general with respect to adjusting to these things? And all of you, or maybe the majority of you, have heard about terminologies like technology, digital, or data literacy. The idea is really, in order to establish analytical capabilities or data-driven decisions, we need to make sure that employees and managers have these literacies. So understanding how technology works, what technologies are useful, what technologies could help improve the output of the firm. And so you have a set of dimensions and levels, right? So there's the social, technical, and cognitive level. Obviously, there's a technical, right? Kind of the understanding of how the technology works, right? Have build a knowledge base, understand digital data and file storage space, et cetera, et cetera. There's a social part, right? So are there particular corporations or team programs or learning strategy, cooperative learning strategies in the company that will support the general technology and digital literacy, but potentially the skills and abilities for certain technologies, specific technologies, whether that's programming languages, whether that's new email programs, whether that's artificial intelligence software or systems, et cetera, et cetera. And then, of course, the cognitive part, which is, can I actually understand, like, how do I learn, or how do I as an individual understand these new technologies? And so, yeah, we have different levels: basic usage, application, development, and transformation. You can imagine, right? So application, applying essentially basic usage is, can I use my email, right? Can I use a computer? Can I use a tablet, right? And it sounds basic, sounds like a little condescending, but it really isn't, right? It just means that you have some basic understanding of using some of these tools. You want to have then, how do you use these tools in the firm, right? So how do you use emails to communicate certain things? How do you use emails to schedule? How do you use emails to discuss? Where are the limitations of these technologies? And so in the application, right, and do you need to acquire new technology or new coordination technology? Think about Microsoft Teams, think about Zoom, right? The application of these seem pretty intuitive, but then finding new applications and improve it and using these applications to improve the bottom line. That's another factor. Again, then, you know, when we know how to use and we know how to apply them in a certain way, we also want to start to do more complex things with data, right, or technology, whether that's collecting and processing data, whether that's using complex equipment, right, to produce certain things, and then ultimately transformation. We want to build complex prototypes. We want to create and transform digital artifacts, platforms. We use coding language, right? So there is a level of digital technology and digital literacy that brings a company to essentially the next level, right? That's what we talked about, the fifth stage of analytical capabilities, which is essentially, now I can use these to change my business model, to produce something, a complex product, et cetera, right? And there's another terminology that's used, and you'll see this in the literature. It's called a digital mindset, right? And again, these things are important if we want to use digitalization to develop new products and services. We need to develop these capabilities and these mindsets in order to get to that next stage in the analytical competition. Now, there is although they have been used interchangeably, there is a difference between digital literacy, competence, skills, and digital mindset. And the difference is, one has to do, the former three have to do with using digital technologies effectively, but the digital mindset is more about attitudes and beliefs towards digital technologies, right? And those can be as important as the actual ability to use something, right? So the ability to think in a digital way, or to think in a digital business model way, is as important as being able to understand and master a technology. And they're obviously intertwined, right? So they're strongly connected. And here is kind of a more extensive discussion on digital mindset. Again, the literature isn't yet that well developed on that, but you have researchers who look into how employees and digital mindset, of course, is used in the context of digital transformation, which is another one of these terms that has emerged in the last 10 years. And here the idea is really, how do I convince employees to use digital tools? And how do I build a program? How do I improve adoption, et cetera, et cetera? How do I improve their confidence to use it, as well as how do I believe how do I improve the employment's belief in those initiatives? And again, so these are, and we can of course separate between the employee and the manager, right? So these are two different things. What does a manager have to develop in terms of their digital mindset, whether they're employees, right? And so these are totally two different discussions that have kind of captured researchers. Important thing here for managers in the new product development era is we can use digitalization to experiment, right? So those tools should not dictate how we run the company, but how the company runs should dictate how we use those tools, right? And so as we experiment with these tools, we will potentially change the processes in the company, right? So although these tools will not dictate how, or shouldn't dictate how we should do it, they will unquestionably influence that. Danger always is to use digitalization to just confirm the hypotheses you already have, right? Or the intuitions that you already have. And here the important thing is, how do I use digitalization or digital tools to generate counterintuitive insights, right? Insight or a variety of insights from which then I can choose the option that seem to make most sense based on the evidence. Again, we can change making decision, it influences decision models, right? How we make decisions in organizations is a big topic, whether it's leadership, whether it's teams, right? Any of these issues, data can help us structure these processes, right? And so we have to think a little bit about what that means. And the reality is, because of our digital integration, or most companies' digital integration, whether it's through social media, whether it's through the Apple App Store, right? We have these tools give us the ability to switch these perspectives, and we have to understand what that means, right? Like if I'm operating an ecosystem like Apple, how does that impact other parts of the company that are focusing on developing, the iPhone, right? And so these kind of different views, whether it's a firm, network, an ecosystem, that these companies are involved in, or the employees, in this case, on an individual level, that those tools help us do that, right? And so that's why it's important to understand these. And you can imagine in a service, in a new service and product development context, figuring out, first of all, what the inputs are, right? Being able to process all the inputs, and then using those digital tools to generate alternatives, or generate plans, or generate, product options or features that wouldn't have been able to be produced without having the data, or without having that digital tool to begin with. And so lastly, we'll talk a little bit about artificial intelligence. Some of you might be very well versed in this, so don't, take this in any wrong way. I'll just provide a pretty basic overview. You've seen, we are kind of surrounded by artificial intelligence, or parts of artificial intelligence already. People have been experimenting with artificial, or have done research on artificial intelligence for decades. Okay. Unfortunately, we just didn't have the computing, or fortunately, I guess we'll find out, we didn't have the computing power to really make a lot of fast progress. And that essentially happened in the last 20, 25 years, where with increasing computational power, we can essentially run a lot of these sophisticated models. And so there are a couple of categories, and you might have heard about them. So the first one is natural language processing. And the idea is I want to have computers, I want to enable computers to understand, interpret, and generate human language, right? Whether that's voice assistance, whether it's sentiment analysis, okay, whether it's machine translation, for example, translate the text from one language to another, or in sentiment analysis, analyze customer reviews and social media posts, right, to determine the sentiment, positive, negative, neutral, for example. We like to do that. The Siri, Alexa, and Google, some of you, maybe all of you have already some of these assistants. And again, there are some concerns with privacy and how, you know, the algorithms are really functioning in those devices. But there we have seen, you know, some real tangible applications for these, for natural language processing, computer vision, and mostly we've seen computer vision in the context of autonomous vehicles. There's this whole facial recognition. There's a whole set of facial recognition applications. They are controversial. There are some, you know, that we need to think about kind of the ethics of them. I've seen these, I think, mostly, I'd say in an airport. There's a few airports now that do these, let you do these self-checkouts in when you go through customs, and they, you know, check your passport, and they analyze your face, and they compare if those pictures are the same. You have a lot of medical image analysis. I don't know if some of you have heard, algorithms and AI applications in general start to become really, really good at analyzing medical pictures, right? Medical or X-rays or any other medical imaging, and so this has been a pretty good, pretty powerful application in AI. Some of these, what we call expert systems, they try to mimic decision making of a human expert, okay, in a particular domain, for example, medical diagnosis, financial analysis, legal advice, etc., etc. So you're trying to essentially mimic how human experts would essentially respond to some of these some of these questions. Again, all AI is doing essentially, right? AI is based on a massive amount of data, right? If AI doesn't have data, it's not very effective. And again, the how we collect the data, what data we collect, that will also determine the effectiveness of the AI system. However, we've seen that certainly AI systems have made a significant amount of progress. And as you can imagine, although we haven't used it yet as aggressively, and I'll talk about this in a minute, the applications for new service and product development are definitely there and becoming more prevalent. Machine learning, and so machine learning is kind of the core application, now is becoming the core application of AI. And there's different categories to it: supervised learning, unsupervised learning, reinforcement learning. I'll talk about these in a minute. You have also other categories or other typologies called generative artificial intelligence, neural networks, deep learning. Generative artificial intelligence you have seen through ChatGPT. That's an example. And that can be happening through both supervised and unsupervised learning. Again, I'll talk about these here in just a minute. And again, this is not a technical class, okay? So I don't expect you to know all the technical details about artificial intelligence. But here is just a basic, I just want to provide kind of a basic understanding. Now, supervised learning, okay, what that means is, again, when we talked about expert systems, right? We want to try to get as close as possible to an expert or an accepted source of truth, right? So an example that's often used is analyzing a picture and predicting whether the subject is a cat or a dog, okay? And so we like to train, and you do this in combination with computer vision, for example, right? You show the computer a cat and a dog, and then you're essentially tagging those pictures for the computer, right? The computer's starting to take a guess or start to analyze, and it will kind of do so until they reach a satisfactory error, a satisfactory low error margin in terms of that. Obviously, humans don't need to be trained. Well, we actually do need to be trained, right? When we're little, we're being told, right? We're being taught the language, and we're being told what a cat is and what a dog is. But so what they're doing essentially is not exactly, I mean, we don't operate like, we do have, in a way, we have algorithms, but as humans, but what we really do is, you, as I said before, right? You're looking at you do a training and you do a validation stage, and essentially, as you collect more and more data, you're essentially asking the computer to identify these features. And if the computer is getting better at it, it's getting kind of a positive signal. If the computer gets worse, there are corrections in terms of human intervention. Okay, now unsupervised learning, which is, sometimes we might want to explore the data, right? So we don't want to tell the computer exactly what we want, right? We don't want to kind of train towards a particular outcome in the example of cat and a dog, but we want the algorithm to find kind of natural groupings in the data, right? And so if we're looking at the cat and dog photo example, we might let the algorithm run free and ask the algorithm to come up with other types of groupings, right? So, for example, instead of cats and dogs, the computer might separate between indoor and outdoor, day and night, and virtually anything else that they can find in the picture, right? So that's a possibility, and we might want to do that, especially in an exploratory phase, where we're not quite sure what we're looking for yet in the data. And because, when we think about product design and we think about kind of product and service design, we, like in an unstructured design process, right? When we remember we talked about design thinking, we kind of collect observations and we don't yet want a certain outcome, and we start naturally grouping the data. And it's kind of the same thing. The difference is that it can go much faster, right? It can go much faster. And it probably, the program or the artificial intelligence yet doesn't have kind of the same intuition as human algorithms have, right? So again, the algorithm stimulates what's called induction, right? So making generalized conclusions based off of specific scenarios, and can do that with an extremely large quantity of data. Humans cannot really process that much data, right? So in scenarios where you have a lot of data, like an exorbitant amount of data, unsupervised learning is the way to go. Like it's hard, you can't let human actors do that. That will take far too long. And it provides insights and hypotheses that essentially mirror or kind of copy the dynamics of ideation and brainstorming, right? Because that's what the computer essentially does, right? You don't give them a lot of guidance. You don't give the algorithm guidance. You essentially let them run free and say, hey, kind of go through the data and just generate some stuff and see if what you generate is actually interesting to us, which is kind of closest to resemble ideation and brainstorming. That can be definitely applied if you're looking for new opportunities, right? Think about new product or service opportunities, and you let the algorithm go through a huge data set of product categories, sales data, customer reviews, for example, et cetera, and see if the algorithm can actually find some interesting options and trends. Now, there's something that's called reinforcement learning, okay? So instead of starting with data or an expert's view of the outcome, we essentially just have a starting point, right? And a performance function. And so that what it means is essentially the system starts somewhere, right? So you let instead of, for example, we looked at unsupervised learning, we had specific pictures, but we didn't care about particular outcomes in those pictures. In this case, we don't even have the pictures potentially, right? So we literally just run the algorithm. So we put the algorithm somewhere, and then we let the algorithm figure out, well, what kind of direction makes sense. And the human analogy is, so imagine you're going up a tall mountain, you walk your way, trying to walk your way down. It's a really foggy day, and now the Power Mountain doesn't have any clearly marked paths, right? So what you're doing, you start exploring, right? So you have kind of a vague intuition, right? You know you want to go down, right? But you don't exactly know which path you're going to take. And so you're going to start to explore, right? And you're going to explore different options. And so you have to think about the trade-off between exploring and exploiting, which in this case means, do I spend more time exploring around the mountain to find the best route, or do I rather stick to a route hoping that that's the right one so I can save some time? So again, if we think about iterations, right? So if we think about design thinking and product design, we talked about how we typically have an iterative approach to developing new products and services. And that's kind of a similar way, right? So we use reinforcement learning here to essentially determine a starting point, okay, and then kind of go through different iterations of the problem and see what can come out in terms of potential product ideas or product or service ideas. So generally, okay, what we've seen is we've seen a heavy adoption of digital technologies, right? And some of these digital technologies, like computer-aided design, have been very helpful in the product development and service development process. They are still manually used, right? So if you see engineers using a computer-aided design tool, they do this in kind of a manual adjustment. It's still, product and service design is pretty human intensive still. Most of what we've seen in automation has happened in manufacturing. But now with AI design tools or AI tools in general, we see a variety of AI scenarios that can unfold, right? So we can use AI to accelerate traditional product service design tasks. For example, you have hand-drawn designer sketches of a customer experience or something else, and you're trying to render that automatically into specifications, right? And if you do a lot of these, you have a computer doing, processing that pretty quickly. It means that you can go through more ideas. You can then use those specifications and do another analysis using the AI. You can make design decisions. So you can delegate design decisions to an AI system, right? And we'll talk about what we call creating a problem-solving loop rather than design specifications, right? So what I want is essentially, I just set up the problem, and then I'll let the algorithm essentially run all the options, and I'll select, together with the algorithm, I help select the options for the design. We typically, right, in order to do that, we'd have to then split it into a human-intensive design phase, right? So we set up the solution space. we start designing the problem solving loops, right? And that means essentially, let's say we are interested in what can we use? Let's say we are interested in developing a new drinking bottle, right? And so we can set up kind of the solution space, and which means, the bottle should be, a 6 inches tall, 5 inches thick. We use this metal, right? We use aluminum, or we use this color, right? We have a few parameters, and then we use essentially the AI to create the options that are within that solution space. And we can play with the solution space, right? So we can add more parameters, or we can remove some parameters. And again, right, we would have to, so we let AI do that, but AI would have to be based on a particular data set, right? So what kind of data set could we provide for that? We might have a data set that we got from Amazon, right, where a ton of these bottles are bought. We could have a database that we developed over time, right, with different inputs, and then we ask the AI, hey, come up with some design solutions given those parameters for new bottles. And so when we think about the solution, right, the different solution spaces that are being used, that has essentially zero cost and time except for computing and storage. And you can potentially, now in the bottle case, we have a constraint with manufacturing. But if you think about digital products and services, there is effectively no manufacturing cost. So now an AI could come up with a completely customized set of digital products, given that we've provided some initial conditions as designers. Potentially, we can provide no initial conditions, right? Whether that will make sense ultimately or not, we'll have to think about that. But essentially, what we are currently trying to do is we're giving the AI a set of simple tasks, which is also called weak AI. So, for example, recognize a shape in an image, or 2 images have different shapes, which doesn't seem like a very sophisticated process, right? But if you do this millions of times, you can actually get pretty complex predictions on potentially complex options that are surpassing human capabilities, right? For which you would have theoretically needed 1 million people to do. You can let the AI essentially run free and create these options for you, given you have enough computing power and storage, etc. And again, the limitation here would be essentially the data set that's available, right? So good data sets will become even more critical in the future, because if you don't have good data sets to train an AI on, you won't get the solutions, potentially the solutions that you would need. And so one of the big questions is, how do you now train engineers and designers who historically been doing this task pretty much on their own, right? So it was very human intensive. They typically don't use AI to generate these different models. They use digital tools to help them do that. But now you have to retrain them a little bit, and they have to create a solution space and then essentially help sort out the solutions that the AI generates through these potentially millions of iterations. And this is just a visualization, right? So this is the typical design process that we have talked about, right? So design, make, use, then you get some insights, then you redesign, and then make, use. You go essentially in circles, right? The iterative process. And again, now with data, right, we essentially can have the AI generate that, right? So we have our design, our product process, right? Think about Tesla. So Tesla is a really good example. They are not yet capable, the AI is not yet capable of automatically producing these parts, but there are so many sensors in the car that collect that data that you can essentially, right, once you set your parameters right, you can let your AI run different design options or product options or product iterations that could be helpful. You can think this even more in Netflix's case or Amazon's case, or Meta's case, right? Think about Meta. They have done lots of experiments with people. Well, not physical experiments, but experiments on the platform, seeing what people like, right? How people respond to things, which kind of buttons should they add, et cetera, et cetera. So this is effectively a way for AI to solve it. And in a software environment, AI can potentially even remove the design parameter. That could be completely automated, right? And AI could essentially develop, right, collect the data, start making changes to the software, and can completely run autonomously, which is one of the concerns that people have, that once we unleash that, we have no more control here, right? Like we don't even put in design parameters in there. The AI can essentially autonomously solve all of this. And again, right? So now the question is less, how do I design products and services, but how do I actually design problem-solving loops that help me, that help in the design and in the development of new products and services? And how do I break these rules down? Although potentially with new capabilities of AI, I might not even have to do a simple task, right? Because AI can actually do this. I could potentially train its themselves and figure out a way to circumvent a lot of these things. And here's just some overview, right? So we mainly think about is AI still as a facilitator, right? So it augments existing products and processes, is a starting point. And then now we've seen more and more AI as an originator, mostly in software, right? Potentially it will happen in hardware, right? So when your production facilities are automated, and you have an AI system that could essentially send in specs and specific orders for producing specific parts automatically, right? Based on what they get in terms of customer reviews, based on what they get from management inputs, that would be pretty wild. So we're not quite there yet, but might be faster than we expect. We do a fair amount of AI. I mean, it's clear that there's a value proposition in the ideation stage, right? So again, we can let AI run different options and different scenarios, and we can use that then to in the development of software with ChatGPT. ChatGPT is essentially giving you the possibility to code, right, without actually knowing how to code too much. And that will become even better. So, you know, all of us who are struggling with writing code or never have written code, now you have a tool that can actually help you do that, which is, you can imagine what implications that has for big software companies and software engineers in general, right? So there will be some changes to that. And again, so we've seen also an increased interest in AI-based startups. How much that is a hype and how much that's real, we will see in the next 5 to 10 years. But certainly, right, so AI as a product and service development machine will become very, very important. Now, a quick example, and you know, most of us have probably a pretty good intuition about Netflix and AI. But as you might remember, you know, most of Netflix's operating model consists of shipping DVDs, right? If you can imagine that, about 20 years ago, as they essentially got rid of DVDs and they use streaming. They also had a website, of course, so they can use they were able to use that as well. But with streaming content, they now had a capability to essentially generate digital data that they can use for any future AI models or for data analytics purposes. You can think about that, right? Think about a problem-solving loop here. You have the data of how people are watching the movie, which movies people are watching, how long they're watching them for, what kind of genres they're watching, et cetera, et cetera. And so you can essentially develop a problem-solving loop now, right? You can automate the design phase, and you can potentially make all kinds of adjustments, whether that's to the website, right? Maybe you add new buttons, or you add new interfaces, but also to the content. And for example, what content you should purchase, what content should you develop. Now with the generative AI tools, I don't know, some of you might have seen, you can actually do videos. AI will produce videos for you. You can fathom that Netflix is using their database or their data that they get from customers, and their viewing data to generate AI-based content, right? That's not a crazy stretch to think of. Again, when we think about different applications of machine learning, for example, so we think about supervised learning, right? We want to label data sets. In this case, what data sets they want to label is certain movies, whether they're liked or not, right? And then you use that to figure out similarities, right, between customer groups. Then based on that, you can suggest effective recommendations, right? Like movies that are similar in a way, right? Based on essentially the movies that you chose or the movies that you liked, right? Because that's kind of what you can do with supervised learning, right? You have these pretty set categories, and the program then starts structuring around that. Again, we could do this manually, right? So imagine you would do this in a design thinking exercise. You have this database of movies, and you would manually label that with humans. You can imagine how much time and how difficult that's going to be with digital products and digital content. AI is essentially the only way to go. Think about another application, right? So typically, all of us have a similar interface, right? When we go to Netflix, we have essentially, it looks like we have the similar interface. Now, there are some changes in terms of the recommendations that we are getting, but imagine that Netflix could use our data to generate a different interface for everybody individually, right? Based on our interests, based on how we use the website, right? Used based on how we interact, how we watch movies, how long we take, etc. And the first application, right, was essentially predict which content to create, right? In the first place, like content creation, which doesn't have this kind of set parameters, but where the AI has to essentially give you a prediction based on the information that they have in those likes and movies chosen. They're claiming that House of Cards was one that was done with predictive analytics, was relatively successful. We haven't seen, other than that, we haven't seen a lot of data around that. So we'll have to see whether how many suggestions that the AI made or that the system made were actually produced in total. But it certainly can help you provide like a general direction. For example, you don't even need to know the exact movie, but you could know a genre, right? Like which genres could be popular, which genres could be successful, that should be produced. So there is still a lot of open space to explore there, but certainly some interesting options that we've seen. So going back to the previous point, right? So when you use Netflix, you have certain, typically you get movie recommendations, right? Or you get certain recommendations in terms of what you should choose. Now, Netflix, of course, figures out, okay, there's a huge diversity in taste and preferences, right, of their viewers. That's not crazy. And then they try to figure out how can I lure somebody, or how can I kind of help somebody figure out a movie, or could potentially get them to watch a movie using the cover artwork. And everybody responds different to cover artwork, right? And so they're trying to figure out, well, how could I individualize the cover artwork for a movie, right? We typically all respond, we have standardized posters, right? Or standardized kind of ways of looking at certain movies. And here they use the cover artwork, but we could also imagine that trailers could be generated in a customized fashion, right? Because we all see the same trailer, and obviously all of us respond to a trailer very differently. But imagine you could actually produce more customized trailers. And so you can use reinforcement learning, because that's, you kind of need to determine a starting point, but then you can let the AI essentially explore. And so that can help do this. Again, they did this with the artwork. You can imagine you have tons of different art, like taking out the frames of, taking pictures or sketching the frames of the movie. You have tons of frames in a movie and a TV show. And so matching the user with the particular frame, right, to improve the recommendation. If you try to do this manually, you'd have no chance of doing that. So essentially, they're doing this through what's called a multi-arm bandit algorithm. And so then you explore the AI explores the options and also exploits the solutions, right? So if it finds something that the user responds to, like a visual that they do better on, whether they click on it or they watch it longer, they can then help kind of help the AI learn and develop future visuals for their movies. And that's it. I hope you enjoyed the last module. Let me know if you have any remaining questions in the class. I really enjoyed working with all of you and having you in the classroom. Again, feel free to contact me if you see any bugs or you want to kind of chat or any questions about the module or other assignments. Bye.